Assalamualaikum and good evening. Today I want to present about the mini project for the subject Engineering Technology Management. For the title, the mini project is a management and evolution of transmission line project. My group member is Muhammad Adib Teh bin Muhammad Sabri, Syed Aziz Afif bin Syed Muhammad Fadli, Muhammad Ashraf bin Muhammad Zain, Muhammad Hazmi bin Muhammad Rozi, and my name is Muhammad Fakrul Hidayat bin Nazri. For the transmission line project, is located at the Kedah, Malaysia. Is a Pendang to Kepala Batas. For the introduction, transmission lines are essential for the efficient and reliable transmission of electricity over a long distance. As demand grows, this project ensures power supply meet the need of household and business by constructing high voltage line and substation. Advanced technologies ensure efficiency and reliability, while careful planning and execution ensure safety. Success projects like the one from Pendang to Kepala Batas in Kedah improve reliability, reduce losses, and prevent outage, benefiting both power companies and consumers. For the objective of this project, first is to understand the design element and technical requirement necessary for constructing and transmission line. Second, to gain knowledge about control system and evaluate the transmission line project. And the last one is to develop skill in managing the scheduling, planning, and budgeting aspect of a transmission line project. Next, my friend continue the presentation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dipte bin Muhammad Sabri. My matrix number is 2112925549. So in this main project is about the management of evaluation of the transmission line project. So first of all, I'm gonna skip to my part, which is about the problem statement. So first of all, the project scope of the project, we need to construct the 35 kilometer of three-phase transmission line, where is the tower spacing will be placed 250 meter apart. So the responsibility we are divided into four. First of all is the project planning, second is the scheduling, third is the budgeting, and the fourth is the evaluating overall project success. Next up is the table of the outline, the timeline of the activity for the transmission line project. So A until P are the activity listed for this project. We will be contract, the award of the key-off meeting. Then we next on the check profile survey and the steel tower design and the prototype test. D we go for the set and the tension design of the template. And E, the standard foundation design. F is the tower spotting of the Beijing. G is a soil invention and foundation uplift test. H we go for section 1 and section 2 we divided for foundation class and construction. And I class section 1 for the tower erection. Section 2 for J is projection foundation, class, and construction. K is a section 2 for the tower erection. Section 3 L for foundation, class, and construction. M section 3 for tower erection and stringing and sagging and tension. And last of not least is the line test and commission. There are 15 activities that we listed, including the expected time or duration of the each activity. Next, here is the measurement of the distance between the Pendang to Kepala Batas, Kedah. So we will place our construction in Padang first, and then we will go outwards straight away to Kepala Batas to 35 km and 250 meter apart of each tower will be placed in Kedah. Next, there are 6 element key that we apply during this project. First of all, is the transmission line, and second, the conductor. The third is the power foundation. Fourth is the insulator and the hardware. Fifth, the grounding system and protection and control equipment. Each of the key point element have its own purpose and work, such as the transmission line is for the steel leg tower will be construct apart for 250 meter and will support the wires and ensure for the safe and reliable for transmission along the transmission line. Second is a aluminium conductor steel enforcement for SAR or all the aluminium conductor for AACC will be used between transmission tower for high electrical conductivity and mechanical strength. This is enable the effective for the power transfer and resistant to various environmental conditions. Third is the tower. We have the enforcement for the concrete for the foundation for the stability support, design and constructed according to the standard of the IS 456 with the minimal concrete weight grade 5M20. The fourth, the insulator and the hardware is a suspension for the insulator made for the pro-seal or the pro-side material will be provide electrical insulation between the wires and the towers. Hardware such as a clip, bolt, clamp, bolt, nuts, and washer will be secure the conductor and the insulator to the tower. 5. Grounding system is a strong grounding system including the grounding rod, cable, and the clamp will be installed to ensure the safety of the transmission and the line protect against electrical issue. Last but not least, protection and control equipment. Circuit breaker, relays, and lighting arrestor will be installed during the protect transmission line and they ensure that for the network remain reliability for the stable detecting and the isolating issue. That's all for me. Thank you. Assalamualaikum.
Hello, my name is Muhammad Hasbi bin Marozi and my metric number is 211293317. So I want to explain about the organization of the project transmission line. So first of all, we have a project manager, which is Muhammad Hasbi bin Marozi as a project manager. So the role of the project manager is oversees and supervise all construction projects. Next, plans and supervise all construction projects, ensuring adherence to protect plans and specification. And finally, we have to manage the project timelines, budgets, and resources. So next, we have engineering manager, which is Muhammad Asraf bin Muhammad Zain. The role of engineering manager is to handle technical initiative and manage the technical staff. Next, to develop and implement technical plans, objectives, and goals. And next, supply technical services and to coordinate them. So next, we have human resources manager, which is Muhammad Fakir Hidayat bin Nazri. So the role of human resources manager is to develop and implement HR policies, procedures, and program. Next is to manage recruitment, selection, and onboarding processes. Finally, to handle employee relations, performance management, and disciplinary actions. Okay, next we have a financial manager, which is Muhammad Hadid Teh bin Muhammad Sabri. The role of the financial manager is to create and carry out financial policies, processes, and strategies, to oversee financial forecast and planning management, and next to create financial reports and analyze and track financial performance. Okay, next we have department development, which is Syed Haziq Afif bin Syed Fazli. The role of department's development is to carry out research to find prospective growth prospect. Next, to evaluation of a project's viability and feasibility. Next, oversees the development, project planning, and design phases. Okay. Next, we have a marketing department, which is Siti Aminah binti Bakar. The role of marketing department is to create marketing plans and strategies to advertise goods or services. Next, to carry out the market research and assesses rivals and consumer trends. And creates marketing programs including public relations, advertising, and digital marketing. So finally, we have a purchasing department, which is Ali bin Bakar. The role of purchasing departments is to locate, source, and negotiate contracts with suppliers, oversees procurement procedures, and ensure product and services are delivered on schedule, keeps track of inventory levels, and oversees supplier connection. Management of the project network diagram. So this is the our project network diagram. We have 16 activities and we connect to each other. Table 3, we have activity. We have 16 activities: predecessor, optimist time, TO, most likely time, T, pessimist time, TP, and estimate time, TE. For table 4, we have activity, which is still activity, and variance and standard deviation. So the formula of to calculate variance is TP minus TO over 6 power of 2. And the formula to calculate standard deviation is TP minus TO over 6. The critical path of the project transmission line and evaluate the expected completion time, ensuring the project management is 99% confident in completing the project. So the critical path of this project is activity A, C, E, G, L, M, N, and P, which is we got 75 weeks. The standard of deviation of critical path is TE square root A power of 2 minus A plus C power of 2 plus E power of 2 plus G power of 2 plus L power of 2 plus M power of 2 plus N power of 2 plus P power of 2. So we got 3.416. If the 99% confident in completing the project, to find Z, which is 99% equal to 0.99. So 0.99 minus 0.5, we got 0.49. So refer to the normal probability distribution table, the value of 0.49, which is the corresponding is Z equal to 2.33, which is formula of Z, Z equal to TS minus TE over derivation of TE. So the Z, we got 2.33 equal to S, which is TS, minus 75 divided by 3.416. So we got the TS is 83. So the expected completion time is approximately 83 weeks if the project management has 99% confidence in completing project. So that's all. Thank you.
To the present transmission plan and schedule of transmission line project. Planning and scheduling a transmission line project is include a methodical procedure to guarantee the effective and punctual completion of overlapping duties. In the particular instance, the activity are arranged in chronological order, which the Duration of each action measured in weeks. The contract award and kick-off meeting activity A mark the commencement of the project. Following the kick-off meeting, the confirmation of the subsequent activity including the profile survey and returns clearance in activity B. Steel tower design and prototype test in activity C, and sec tension design and template in activity D is depending on it. Now we go to the project network diagram. The project network diagram provides a clear visual representation of the connection between the activities and enabling the project manager to easily identify the vital connection and allocate the resource in an effective manner. For example, tower spotting and pegging activity F really on the completion of activity B, C, and D, which together create a critical pulse. Similarly, in soil study and foundation uplift tests in activity G are depending upon the successfully execution of operation C and E. Activity H, I, J, K, L, M, N, and P show a consistent pattern where the order of completion in if completion is influenced by the completion of previous tasks. By enabling a complete planning approach, the project network diagram play a vital in ensuring effective project management and timely completion of the transmission line project. Thank you.
Okay, thank you. My name is Syed Haziq Afif bin Syed Muhammad Fazli. My matrix number is 2112911032. Okay, I will proceed the presentation about estimated cost for the transmission line project. There are 4 types of costs that we must include in this project, such as the concrete cost, direct cost, indirect cost, and lastly is the total cost. For the direct cost consists of several items to be calculated, which is labor cost, material cost, equipment cost, testing and inspection cost, and site utilities cost. Okay, firstly is the concrete cost. For the concrete cost, they have several items to be calculated to get the final cost. The several item, which is the total number of towers, total of holes needed to be digged, volume of concrete per hole, total volume of concrete for 140 towers, and lastly is the total cost of the concrete. Okay, as we can see, here is the table for the calculation. I will go one by one. Okay, firstly is the total number of towers. By using this calculation, which is length of the transmission line divided by the distance between each line tower, in this project, we use 35 km as the length of the transmission line and 350 meter for the distance between each line tower. So 35 km divided by 350 meter and we can get 140 towers. Okay, next, number 2 is total of holes needed to be digged. For one tower has 4 holes, so 140 towers times 4 and we can get 560 holes. Okay, next is the volume of concrete per hole. In this project, we choose LST, which is lattice steel tower. So the size of hole, as we can see, 4 feet times 4 feet times 30 feet, and you can get 480 feet cube. So we convert it into meter, which is 1 feet cube is equal to 0.0283 meter cube, and then for 480 feet cube is equal to 13.5921 meter cube. So next is the total volume of concrete needed for 140 towers. For one towers, 480 feet cube times 4 holes. Okay, we can get 54.36835 meter cube. For the whole tower, for the whole transmission line, is 54.6384 meter cube times with 140 towers, and can get 7611.576 meter cube. And then we round it out and estimate is 76.12 meter cube. Okay, and lastly is the total cost of the concrete. Based on the current market, the price for ready mix concrete is RM 243 per cubic meter. So the total cost is the answer we get from before this times the price of the ready mix concrete. We can get 1,08,049,716 ringgit. Okay, next is the direct cost. Direct cost refer to expenses that can be directly attributed to a specific project, product, or service. These costs are directly associated with the production of goods or services that and can be traced back to the cost object without any need for allocation or estimation. As we can see, here is the all of this is under direct cost, which is labor cost, material cost, equipment cost, site cost, utilities, and testing and inspection costs. So the total of all of these is 105,746,346 ringgit. Okay, next I proceed to the indirect cost. Indirect costs, also known as overhead costs, are expenses that are not directly traceable to a specific product, project, or activity. These costs support the overall operation of an organization and are necessary for a business to function, but they cannot be directly attributed to a single cost object. As we can see in this figure, number 1 is the insurance, number 2 is the quality checks, number 3 is the commissioning expenses, and number 4 is documentation costs, and lastly is the telephone bills. Total for this is 109,000 ringgit Malaysia. Okay, lastly is the total cost of this project. First, the direct cost consists of the labor cost, material cost, equipment cost, testing and inspection cost, and site utilities. For the indirect cost, which is insurance, quality checks, commissioning and expenses, documentation costs, and telephone bills. The total cost of this project is 106,250,356 ringgit Malaysia. Okay, next I will proceed to the monthly cash flow diagram and depreciation of the crane. As we can see, here is the figure of the cash flow diagram for monthly. Okay, next, the company set the crane with price of 2 per 3 of the initial price. The price of crane is 180,000 ringgit. The selling price is 2 per 3 of the initial price. So 2 per 3 times 1,1800 ringgit, and we can get 1,200 ringgit. Cost for the maintenance of a crane is 25,000. For every 2 months is 500. Okay, next, the expected time of 99% confident of completing the project is 83 weeks. 83 weeks is equal to 19.1013 months and approximately 1 year and 6 months. Therefore, N is equal 1.6 years. Initial asset value B is 180,000. Asset resale value S is 120,000. So by using this formula, B minus S and divide by N, we can get 37,500 ringgit. As we can see the table here, for the first year, the depreciation in year is 30,500, and then the total depreciation up to year is 37,500, And then the book value of the end of year is B is minus to what you call it, the sum up of the total depreciation. You can get 142,500 ringgit. In second year, the depreciation is 37,500, and then the total depreciation up to year is 75,000. And then the book value for the second year at the end of the year is 1,500. So as we can see, the value is decreased compared with the first year. Okay, that's all for me. Thank you.
For conclusion, overall the proposed 35 km three-phase transmission line project from Pendang Kedah to the Kepala Batas Kedah aims to meet the region's growing energy needs. The project includes design elements, technical criteria, and cutting-edge protection technology. It focuses on the solid concrete foundation, suspension, insulator, and hardware. Environmental consideration, right-of-way, and safety law are crucial. The successful implementation will improve power transmission efficiency and contribute to the region's long-term growth.